So, good morning, everyone, and hi. Thanks for joining this session. I am very sure this session will be very, very exciting and helpful. And we would like to interact with you as well and would like to learn and see many new things from you also. So, I'm also thankful to Zinnov for providing this platform. This is very interesting platform wherein you can share the knowledge and you can learn and you can interact with the industry experts. Uh, mm, I'm Girish. I'm working as a senior director in Samsung Research India since past 20 years. And one important thing is Samsung Research India Bangalore. It's Samsung's largest R&D center outside Korea. Samsung has around 30 plus R&D centers, and this is the biggest R&D center. And here, of course, we have many technology verticals, but one important out of them is in camera and visual intelligence. And me as well as Alok both are working in this prestigious department. And we are very proud of this technology vertical because this is also a center of excellence for Samsung. And we all have been working on cutting edge technology and research for the Samsung. And our research and our features are mostly deployed in Samsung flagship products. Samsung R&D also is very influential in filing IPs and patents, and we have received many awards, especially in patent filing in India. And um, many important India-centric innovations also have been deployed in our Samsung products. So today, this is my second session with Zina, but today I'm more excited because last time when I presented, I was alone. But today I have a very young, dynamic, talented colleague with me, Alok. Good part is yesterday I completed 20 years in Samsung, and Alok also has been with us since 19 years. And we are working in the same team. So our collective together experience is 20 plus 39. And together we had very exciting experience of R&D as well as deploying very interesting and cutting edge technologies with Samsung. So over to Alok.
Thank you so much, Girish. I think your leadership has been amazing. And good morning, everyone. This is Alok Shukla, and thanks for joining this session. I hope you all are doing great. So, I serve as a director in visual intelligence team, and I lead a team of dynamic researchers who are specialized in generative AI, visual AI, computational photography. The main focus of this team is to develop cutting edge features for Samsung flagship devices. We have also pioneered the latest generative AI features into the Samsung flagship devices. So my team has played a pivotal role in bringing these generative AI features into the Samsung product. Overall, at Samsung, we focus on continuous innovation as well as breakthrough thinking to bring the best visual experience to our customer. And that's where I think this R&D center has been playing a very important role, as Girish mentions. So before ado, let's start and begin our session. Over to you, Girish.
Thank you. We'll begin our session now. Let me share my screen. So as Alok mentioned, our recent offering is Gen AI features, and you probably would have heard the Galaxy AI is here. So we are very proud of the achievements by SRIB, and we'll continue to launch many such features. So today's topic is also related uh, almost to the same. So the most important question is, so why this topic is important? Camera, visual intelligence, and why we are saying it is evergreen playground for timeless innovation. So as I said, I joined Samsung 20 years before, and when I started working, that time I was working on a feature phone, and camera was just introduced in the feature phone, and the main purpose of the camera was a video call, and it was only on the front side, and the resolution of that camera was QCF resolution, which is 176 cross 144 pixels only. And today, the smartphone is evolved so much that we are having 200 megapixel camera. So we can see in this last 20 years, the camera has upgraded almost 7,800 times. And of course, the major focus was continuously improve the image quality. And one of the key objective behind this was how we can make image quality very similar to DSLR. Of course, DSLR and smartphone are totally different products, but this was one important thing. And uh, that is the reason you see every year was very very exciting, and it was not an easy journey. And today, if you see, the camera has become a key buying factor for the smartphone. Any brand you take, but the first choice for the consumer is always what is the camera quality. And most of the smartphone are selling because of the very good camera capture quality. So the camera has evolved a lot, but that's not the only reason. Because of this advancement in the camera, you can see it has pushed the limits of sensors, hardware, processor also. So there is a heavy growth also in semiconductor. And another important aspect is camera is not only about pixel. It also started understanding the environment, because camera sensors and a lot of other technology is also coupled with AI. Because of that, camera has started detecting the objects, recognizing the object, and it also started understanding the 3D world. And when it is coupled with multimodal recognition, you can imagine how powerful this overall proposition would be. It is like the way our eyes interpret the world and our brain understands and take the action. So it is that much powerful. And when this much power has been gained, I'm very sure even in the future there will be many products, many use cases, and things will be totally different because of this major technological advancement happening. So in the last 20 years we have been seeing the continuous innovation and enhancement in this area. At the same time, we are very, very hopeful because of AI and a lot of other things coming into the industry. The camera, visual intelligence, and many other multimodal recognition will make this specific field very, very important, and innovation will continue. So let us see how much is the impact of camera on our life. I'm just showing you some cameras which are very very visible to you. So of course, one important product is the smartphone, which everybody has. Then we have a digital camera. Then we have movie camera, surveillance camera, wearable, automotive, drones. So these are very very important. But if we look at our life, I get up in the morning and first I unlock the phone because of the face detection, because camera is seeing. And after that, I see a lot of in the Instagram, Facebook, and in WhatsApp. I see a lot of contents which are actually created somebody by using the camera. And of course, when I start going to the office, I see the camera is also used in my car. When I go out of my apartment, there is a proper security system all the time watching through the camera who is coming, who is going out. When I go to the office, my productivity is enhanced because I can interact with anyone.
So, as Girish was mentioning, now today cameras are not only about the pixels, but slowly camera is transformed from hardware to intelligence. So, coupled with the latest AI technologies, now today's cameras have become more and more intelligent. They are capable to understand the dynamics of the scene, understand the context of the scene, what we are capturing, and that's how they are providing much more enhanced user experience to our customers. With the recent advancement in terms of generative AI, now you can have more creativity at your hand using your cameras. So not only you can just capture the scene, but you can actually do and add your creative content to the capture scene and make it share worthy. So slowly, this whole field is evolving, and it is giving a lot of opportunity for innovations and the product differentiations. In terms of technology and market share, I think there's a large landscape for the AI cameras, starting from the biometric, where it is basically concentrated in terms of image sensors, processors, memory, and the biometric. Going in terms of technology, initially the technology was focused on computer vision and the traditional way of solving the problem. And very recently, the deep learning and generative AI technologies have evolved, and they are empowering multiple use cases in terms of IoT, robotics, edge computing, and also going into the multimodal recognition engines. In terms of different products which are empowered by the camera, of course, a smartphone is one of the most popular use from the camera. And of course, there are DSLRs who are used for movie shooting and having the professional grade images. AR has been a new field, and there are a lot of work happening to have AR available at any instance. And that's where not only a single camera or multiple cameras, the whole surrounding of the environment has been captured using the array of cameras. Medical imaging traditionally has played a very important role, and today, with the advancement of the AI, a lot of genetics as well as the medicine has been used using the AI technologies and the cameras to do the imaging as well as find the diagnosis for it. Going into the connectivity, where it focuses mostly on the compression and transmission of this data. And that's where how do we upload or provide this content to shareable content. And that's where the important role of compression plays an important role. In terms of this landscape, there are almost all the big companies who are actually touching this space, starting from Samsung, who are mostly focused on the product development. And then we have Qualcomm, Sony, Nvidia, and Google, who are spread across all these domains. So in today's talk, we are going to cover the end-to-end visual experience. The visual experience starts from the capture, where the image is captured in the form of pixel and projected on the sensor, and then eventually encoded in the form of a JPEG image. We Above this, we have a special capture where using the AI technologies, you can transform this capture image to more meaningful output. And once the capture scenario is completed, then it comes to the gallery. And that's where the visual experience proceed further with the search, where you can try to search the content which is captured. You can edit the content in a useful way, the way you want to convert and has the customized editing to your content. And then eventually able to share this content to a different social networking sites or to your family and friends. So if you look at the traditional ISP pipeline, it starts from the camera sensors. So the camera sensors basically have the array of RGB pixels, and they are being placed in a different form. And this is called a kind of a Bayer pattern. Once the sensor captures the image, it goes through a lot of processing before it gets converted into a useful representation, which we see in the images, which is like a JPEG images. So before we convert the images from sensor to a JPEG image, it goes through a lot of processing, which is called ISP, which is the image signal processor. Here we convert the image into different format. We do some kind of white balancing, demosaicing, enhance the image in terms of sharpness, denoising, and then convert this image back into the RGB format, and then encode and present it in the useful format, which can be represented into multiple devices. So the key challenges in terms of bringing the image quality to a superior quality like DSLR. Very recently, we have seen that from the traditional cameras, what Girish just mentioned, that earlier the cameras were only very small resolutions, just like QSIF. And slowly over a time, the cameras have evolved in terms of the pixel and the sensor size. And today we have up to like 200 megapixel cameras available on a smartphone, very small form factor devices. And there's a limitation in terms of dynamic range and noise. And that's how we will overcome these by doing some kind of software processing with the use of AI to improve the dynamic range as well as reduce the noise of the input images. The smartphone cameras usually, because of the small form factors, have a limited depth of field. And with the advancement of the AI, we can actually simulate the depth of field with the processing. And that's how you improve and bring the DSLR-like quality images into the smartphone devices. Without missing a moment, we have to capture all the scenes. And that's where the cameras are becoming more and more intelligent to capture the scene, understand the scene, and make decisions automatically without the user interventions. Today, the smartphone are equipped with high processing units, and they are able to do computationally expensive tasks in a fraction of milliseconds. So this provides a lot of opportunity for system architects to build end-to-end use cases, leveraging all the hardware and software capabilities of the smartphone and provide the best of the user experience to the end customers. Now, if we just do a single click on the image, just by focusing the camera or a point shoot camera onto a device, so many times you will have the problem that the image may not be focused. So the object which you are trying to capture may not be focused. It cannot be it can have the problem of underexposure. That means the scene is not well exposed and you have a problem in terms of the lighting. So these are the multiple problems which we can encounter if we have the raw capture from the scene without having any intelligence. So these kind of problems are being solved by using multiple technologies which are empowered by AI. So for example, we can denoise the image by using the multi-frame or single frame technologies. We can improve the dynamic range as well as the brightness by combining the multiple exposure of the frame and then give the best user experience, covering the both dynamic and the large dynamic range of the complete image. We can create a sharper image by using AI and make even every pixel visible and to the best of its quality. Now coming to different kind of noise, loss of details, and non-sharp regions, especially because of high motion, there is a possibility that the images will get blurred, and that's where today's advanced cameras have the automated aperture as well as the shutter speed control. So based on the scene, they understand the scene and then control the shooting speed so that they always get a sharper image. The light plays a very important role, and today using the synthetic relighting, we can create the new kind of content which represents like real DSLR level qualities. Now, these are the some of the features which smartphone cameras are very popularly using and which are giving it a quality which is very similar or closer to the DSLR quality. So portrait, one of the very important feature, and this feature actually provides a depth of field effect, very similar to the quality of a DSLR camera. And this basically gives the quality of the smartphone camera matching very similar to a DSLR. Best moments, this when we are having a birthday party or having a gathering, it's very difficult to capture every moment, and many a times we will not be pressing the shutter speed shutter on the right time. So we can give that control to the smartphone, and it understands the expressions, understand the content which are present in the scene, and then automatically take the calls to capture the best moment automatically without the user interventions. So the today's smartphone cameras are become more and more intelligence in terms of understanding the event, activities, and the context. In terms of beautifying and improving the image qualities, today not only just the pixel level, but we actually go into a level where we try to segment the region of the scene, do a different tone control to a specific region of the scene, do the skin tone control, have more texture on the hair regions. So the region specific content improvement has been done and provide the best quality for the output results. The smartphone cameras are becoming more and more intelligent, and with the help of the underlying foundational model or the large models, you can actually convert or do the translation of any text into a more appropriate representation or the language which is more understandable to a specific user. So for example, if you're visiting a foreign country and you don't understand the language, so you can just point your camera and then it will do an in-place transition, and then you will able to understand exactly what is written on the document and able to translate that just using smartphone cameras. You can actually have more detail about the specific region, like just by pointing to the camera, it will give all the details about what is being the scene and give the history about the region, give more details about what is the content represented, and you can search and have more detailed explanation about the scene which is getting captured through the camera. So in nutshell, we have seen that AI is helping to improve the image quality of the cameras and getting it to more to the DSLR images, as well as it is providing the abilities to have the special capture which are needed for the today's customers. Now coming to how do we solve these problems, right? Like the smartphone cameras have a limited depth of field. They have a small sensor size compared to the DSLR images or the DSLR sensors. So how do we match the quality of the smartphone cameras to the DSLR? So that's where we use multiple techniques and leverage the power of AI to transform those images to the DSLR quality. To take an example of multi-frame computational, just as we know that because of the limited dynamic range, capturing all the large dynamic range of the scene with just a single shot is may not be possible. So using the multi-frame processing, the cameras capture multiple different exposure images covering the whole dynamics of the scene, and now these multi-frame frames are fused together to address the dynamic range and improve the dynamic range, as well as the reduce the noise of the scene by giving the crisper and detailed and very smooth output images using the multi-frame technologies. Using the AI scene understanding, now the today's smartphone cameras are able to understand the scene. They are able to locate, localize, as well as segment the regions of the scene, and then take the appropriate action in terms of adjusting the exposure 3A as well as the dynamic range of the scene and capture the best of the image quality. Now we have seen that the DSLR cameras, because of the large lens capabilities, they are inherently able to provide the smooth depth of field effect. But getting the similar depth of field effect is not possible using the using the smartphone camera sensors. To solve these problems using the AI techniques, we can have a single image based segmentation as well as have the depth estimation using a single camera and provide the same DSLR effect by just using a single camera. So with this advancement, lot of capabilities which are currently present in the DSLR cameras are getting translated to a smartphone just with a single camera. So further, there is a better understanding of the context. Right now, the smartphone cameras understand the context of the scene, they understand the actions, and they understand the expression of the and emotions of the customers, and then they are intelligent enough to take the appropriate action or also change the dynamics of the scene to improve the overall quality of the overall scene. As well as today they are not only focused on human but also they are actually able to capture the dynamics of the pets as well as have the crisper quality even with the high motion captures. Now to get the best image quality there are certain things which will play the important role. The first is in terms of the AI fusion. So traditionally, the fusion of the multi-frame frames has been happening using the computer vision technologies, but there are limitation of that, usually in terms of how do we fuse the best of the dynamic range from the multiple frame. And that's where the AI fusion has played an important role. So by using the latest of the AI technologies, we can compensate the motion between the multiple frames to a more effective way by thereby reducing the ghosting and bringing the best of the image quality from multiple frames, and then fuse these multiple frames together to create the final image quality. Now, bringing the AISP, that means using the AI technologies for the ISP, that means the image signal processing technologies, you can reduce the noise, you can improve the dynamic range, as well as reduce the blur in the final image, and then get the best quality in terms of the JPEG captures. Once the image is captured and converted to the RGB, there is a further post-processing which can be applied in terms of enhancement as well as finally encoding that image into a more suitable format and then saving it into the gallery. So by combining the multiple frames, AISP and post-processing, we can improve the overall quality of the image to quality which matches to with the DSLRs. Going into the more deeper understanding of the scene has also played an important role by adjusting the camera characteristics as well as providing some special capture features to the consumers. By having a single class or the multi-class instance segmentation, we can actually do a better focusing, control the dynamic range, as well as always keep camera focused on the subject whenever it is moving or having any dynamics. As well as there are better representation in terms of segmenting the scene and addressing each constitute region of the scene in a more better way and controlling the camera parameters specific to that region, and that's where improving the overall quality of the scene. So we discussed about providing the DSLR like depth of field effect using a single camera. So usually when you have a single camera, there are still some limitation because it is not capturing the real scene in a two multi-view paradigm. So using the multiple cameras, you can actually capture the multi-views of the scene, and then using this multi-view, using the parallax effect, you can actually estimate a very highly accurate depth map. And with this depth map, which actually represents the depth of the scene, and we can provide a variable level of blur on the scene and then control the depth of field of the final image. Using further into from the 2D to 3D environment, basically using also with a single camera, you can actually use a single view geometry of the scene and leverage the power of AI to convert this into a depth map. So usually, traditionally, people have used dual camera to understand the depth and then estimate the depth of field. But with the AI, we can actually use just the single view and actually able to get the depth map as well as the segmentation map, and then apply further improvement in terms of matting, where you focus on bringing the finer details around the hair region or the skin region, and then get the best of the image quality using the background blur. So just by using the single camera, you can get the similar effect which is possible with the dual camera. Further, you can actually capture multiple scenes and have the best moment captures automatically using the intelligence which is inbuilt in the smartphone cameras. So just by doing the point and shoot and let the camera take the action for you and capture the best of the scene automatically and create a useful stories which captures the best of the moment of the scene and saved it into their gallery. Now we have seen that just by the single capture, there are certain limitation in terms of dynamic range. So here we are showing some examples. If you shoot just by single traditional cameras and just you use the pixel processing, you will end up into the image which looks like this, which has problems in terms of dynamic range, and as well as there's a lot of area which are underexposed. But using the AI and doing the multiple frame processing, you can actually improve the overall dynamic range, make the images much sharper, as well as improve the overall detail and the appearance of the overall image. So you can see that there is a huge difference between the images present in the left and right. Further, even in the outdoor scenes, when there is a good dynamic range, sometimes the smartphone cameras are limited to capture everything in a single shot. And that's where using the multiple frames, multiple frame fusion, you can actually increase the dynamic range, sharpness, and overall aesthetics of the image and make it much appealing. Similarly, in the night scene, because of the sensor limitations, as well as the low signal to noise ratio, you will end up into the loss of noise in the scene, and also the images will look blurry. However, using the multiple frames and having the exposure bracketed images, you can actually overcome the noise characteristic by doing the fusion of the multiple frames, as well as increase the sharpness of the overall image and improve the dynamic range as well as brightness of the final output. So you can see how you can improve the image just by doing the multiple frame fusion and the better ISP processing and get the highest quality of the images with your smartphone cameras. So moving on to different kind of special capture scenarios. So here we can actually provide multiple different effects like special capture effects using the smartphone cameras. And just the technologies, what we just mentioned, using the depth, using the segmentation, you can actually give much more user experience to the customer, and we call it as a special captures. So you can actually apply the background blur, you can apply the aesthetically appealing bouquets and the bloom at the background. You can provide the relighting to the scene, which looks very appealing. We discussed about that you can just have the translation of any document to what languages you want to, and then using the single take technologies, you can capture best of the moment and create very appealing and share worthy content in a very short period of time. Now, moving on to the next session. So until now, we covered the journey from the sensor to the ISP processing and then saving the image into the gallery. So this part is called the capture part. And now we will focus on the visual experience post capture. So even in today's journey, the smartphone cameras are leveraging AI to improve the overall experience in the post capture. So in this part, today I will discuss about three verticals in the post capture. The first important vertical is search. So how do you retrieve after the images are captured and saved into your gallery? How do you retrieve that image and utilize those images for your purpose? Second is how do you further improve the quality or the customization on the image by using the latest of the AI edit technologies, and then eventually share this content to your family and friends. So let's begin the search. As we know, search is very important aspect, and it helps us to retrieve the content which are present in a very unorganized way into the gallery. So as we know, our gallery is a collection of our personal memories. However, our gallery is highly unorganized, and it is not in a structured way. So with the advancement of the AI technologies, now we can use the natural language search, and by just simply typing or saying a command, you can retrieve the specific content from your gallery. For example, in this scene, I just want to search the images of Leslie dressed up as a Superman. And just by giving this natural language search, I can retrieve all the contents which represent my search query. Further, I can actually search for things. I can just give a command, give me all the images of donuts, and you can retrieve all the images of the similar search from your gallery. Further, you can actually create a meaningful stories from your content. You can just give a command saying that, okay, just make a summary of my summer vacation, or make a highlight video from my summer vacation, and it will create a very meaningful output representing your whole summer vacation, and which is share worthy, and you can immediately share with your family and friends. Furthermore, with circle to search, you can create or search any content by just simply scrubbing around the content and retrieving it from your smartphone devices. So here, by just simply circling on the screen, you can retrieve the content, get more information about the content, where you can buy, how you can buy, and more content in terms of explanation about what is present in the scene. Now, the basic building blocks for this search is in terms of image classification. So the basic engine is in terms of image classification, and that uses the building block of vision transformers. So vision transformers have emerged as the building block for image search and the classification engines. And we here use the multi-head vision transformers, and each head is responsible to capture a specifics about any specific object. And with that, we will able to label each image, and then this image gets labeled and the knowledge graphs gets built. Once the knowledge graph is built and the gallery will get indexed, now for any new query, we search that index from the gallery index, and then we retrieve the images based on the specific queries. So vision transformers plays an important role, and the one of the advantage of vision transformer is here the image is represented in terms of patches, and these patches are non-overlapping or of fixed size, and these patches are then further converted into 1D vector, and these 1D vectors have different weight and have different kind of self attention. By giving this kind of self-attention and different weight, we can actually have global as well as local context for the scene, further improving the downstream task of visual understanding. So the recent transformer architectures, they basically take the image, divide it into the multiple patches, embed this into a 1D vector, and then using this transformer, these vectors will go as a token to the transformer, and this can be weighted differently. And with this mechanism, you can provide the self attention and the global attention to the scene, and thereby improving the overall visual understanding part and improving the accuracy of the downstream task. Now, these vision transformers have found their application and uses into multiple different domains. And we just saw one of the example is image classification. Apart from image classification, they are also used in image captioning. So you can just give an image and ask the network to predict what is happening in the scene. And for example, here a man is playing football, a dog sitting on the edge of the sink, or a woman dancing. So by using these technologies, you can actually build multiple new use cases. Not only here, you can actually do object detection, instance segmentation, classification, and so on and so forth. And these technology components can actually empower multiple different use cases in the industry. Moving forward to the editing journey, and this is highly influenced by the latest of technology in the generative AI. So here, using once the images are present in the gallery, you can actually further improve in terms of image quality. So by using multiple AI techniques, you can actually help and improve the quality of the images which are present in the gallery. You can have super resolution, you can unblur the images, you can denoise, or you can improve the dynamic range of the scene. Sometimes when we capture the images, they suffer from multiple unknown artifacts like reflections, shadows, or moire. And using these AI techniques, you can actually get rid of those artifacts, and of course, can also provide different kinds of special effects. With the help of generative AI, you will able to remove the unwanted objects from the scene. For example, when we are capturing our best of the scene, and there is always some unwanted objects present in the background, and with the generative AI, you can actually just mark and remove these and fill this in a more realistic way. So not only you can remove the unwanted objects, but you can also add your favorite object in the scene by just simply scribbling and then bringing your favorite subject in the scene. So this provides a tool for your creativity and creating a share-worthy content uh, for your customers as well as for your consumptions. Now, going forward, we can actually create a stylized portrait from a single image and unfold our creativity by creating a different avatar of yourself. Moving on, how we improve the overall quality of the images present in the gallery. So usually our smartphone cameras is, as we know that the gallery is a collection of a lot of images, and these images are actually taken from your smartphone, or some of the images actually you have taken long years back, and they have been present in your gallery. And they are, some of the images you would have downloaded from SNS or as well as shared by different your family and friends. So this there is a large variety of in terms of quality of the images which present in the gallery, and we want to provide a uniform experience to the customer. So how we can improvise the images by analyzing them and then further improving the overall quality and making them more appealing. So here we use a technique called remaster. So here first we understand the scene in terms of understand the quality of the image present in the gallery, and then we do on-device processing to improve the overall quality of the image and then save the image back to the scene. So by using this, we can improve the quality of the images which are present in the gallery. So given an example, if you have a blurred and a noisy image into the gallery, you can just improve the overall quality by remastering it. You can improve the dynamic range. You can remove the blur from the scene and make it much sharper. And you can also remove the unwanted artifacts like shadows from your scene and make it overall much appealing. Moving on, with the latest emergence of the generative AI technologies, you can unlock different opportunities, and actually you can have revolutionize the way you create, pursue, and engage with the visual content. So there are some examples of the creativity what you can unfold using the advancement of the generative AI techniques. So for example, you can create a different kind of creative concept. You can simply sketch content and then convert it into a real image. You can create a different kind of stickers by using just simply typing or giving an anchor image. You can remove the unwanted object from the scene and make it more cleaner. You can create a different kind of expressions and avatar from the scene. And also you can provide improvement in the image quality by having the infinite zoom or the super resolution in the images. So these generative AI technologies are becoming more and more popular, and they are being used across multiple devices. Now, if you look at these scenes or the images, they look almost real, but they all are being generated using the generative AI technologies. So these today's the foundation models have improved to an extent where they are able to create realistic, aesthetically looking pleasing, and as well as real images which resembles to the real scene captures. Now, with the advancement of the generative foundation models, you are more focused on providing the better quality and providing the high fidelity in the images. So slowly, if you look at the scene in this, over a time, the images are becoming more or more towards the realistic, and also addressing the important aspect or aesthetics of the scene. For example, here, if you look at, even though it is a generative image, it is covering the small details about the reflections and the eye colors, and all the details are being preserved very well into the output images. If you look at the previous diffusion models, they were not very capable to represent the text in a very realistic way, and also they were having the difficulty to adhere to the prompt given by the user. But the latest advancement, we see that now the adherence to prompt has much improved. They have better human alignment in terms of the output generated. So the output which is generated from these diffusion models are liked by the humans and perceived in a better way. And also they have improved the quality in terms of the text generation. Moving further, the technology has evolved to make these diffusion models much faster and reduce the number of steps in the diffusion model so that the results can be generated in a much faster way and on a more low end or low computational extensive processing units. There are different class of generative models which we have seen, and traditionally we all know with generative adversarial networks, GAN have been very popular to create a new content where they basically balance between the generator as well as the discriminator. So the generator is actually the objective of the generator is to create the false or the negative samples, and the real samples and the negative samples are fed to the discriminator. The objective of the discriminator is to discriminate between the real and the fake samples and then penalize the generator back so that generator learns to create real samples. So over a time, slowly the generator evolves and start preparing the samples which looks very real. And by using these kind of technologies, we can create the images which are real life and which cannot be distinguishable from the real samples. Further, the auto-regressive networks, they basically divide the input images into the multiple token, and they learn from the code book, and using the encoder and decoder architectures with this learning through the code book, they can create realistic looking images in a very quick and effective way. Further, you can improvise the autoregressive networks using the non-autoregressive transformers, where instead of serially tokenizing these images, you can actually use a parallel processing and use these mask guidance to convert these images into a parallel form and then create the final image in a more effective way. And the later, we very recently, the diffusion models have become very popular, where the objective is to learn the representation of the image, moving from a true image to converting into a complete noise. So this is called the forward pass. And then converting this, once we learn this forward pass, we can actually convert this image back from the noise into the real scene. So by using this forward as a backward pass composition, the diffusion models are able to learn and create real life images. So usually the diffusion models are part of contains three different building blocks. The first is the variational autoencoder, second is the conditional text encoder, and third is the unit. What is the denoising unit? So let's cover each topic in a very short way. So variational autoencoder. So usually the images are represented in the form of pixel, but because these diffusion models are very big models, representing that or processing those higher pixel images is very computationally extensive and very extensive in terms of processing. So the latent diffusion models have evolved where they convert the pixel domain input images into a latent representation, thereby reducing the size of the input image and then doing the diffusion process in the latent space, which reduces the memory as well as the computational cost. And then you have a different kind of conditioning. So this conditioning is basically in terms of what kind of content or what kind of guidance you want to give to your unit latent diffusion to generate the final output. So it could be in the form of text, or it could be form of semantic map, or it could be in the form of input image. So this conditioning, at least in a nutshell, gives the guidance to the unit what kind of output images it has to create. For an example, if I give conditioning as a text and I say that please create an image of a dragon flying on the sky, then denoising diffusion has understood that it has to create that specific content, and then it will try to represent and create the content which resembles or follows the conditioning which is given from the conditioning network. So how do we create a good diffusion network site? So latest advancement, we are seeing that the image quality or the generation quality of these diffusion networks are coming very close to the real life images. And there are fundamentally three different aspects which we can actually work on to prepare a good generative foundation model. The first part is data. So we know that in terms of data, the diffusion networks are actually trained in the form of text to image pair. So for each image, we create a text caption representing the content of the image, and then that image and text pair are given as a data to the diffusion network, and then it learns to represent and gets the embeddings of text as well as image together. Now, traditionally, this data filtering was not being very popular while creating the diffusion models, and with the latest advancement, people have actually started focusing on making the caption more descriptive, improve the overall quality of the caption, and thereby increasing and improving the quality of the data and improving the overall accuracy or the presentation of the foundation model. In terms of architectures, the diffusion models usually have been tailored to use the unit-like architectures. But very recently, with the advancement of the transformer architectures, many of the diffusion models have adopted the transformer architectures, and thereby using the self-attention and multi-head attention, they improve the overall quality of the images. Further, in terms of the training paradigm, as well as improving the overall computational cost of the diffusion models, there are multiple techniques which are very popular in terms of reducing the number of steps, using a different kind of samplers, as well as using different kind of distillation techniques to reduce or fit these complex architectures into a very smaller network, giving the same quality as perceived from the complex architectures. So by using these different techniques, very popular available foundation models have shown significant improvement in their quality of the generation content. So this is the example of SD3. So SD3, in terms of data, they have done the recaptioning of the complete data and have used the T5-like text encoder to improve in terms of data. In terms of architecture differences, they have adopted the diffusion transformer architecture to improve the overall quality. And also in terms of training paradigm, they have used the rectified flow to improve the overall the loss function and the convergence. So by using these kind of techniques, the recent advancement, the quality of the diffusion models have improved significantly. Now, using these diffusion models, we can build multiple different use cases. But these diffusion models in traditional has are very bulky and very heavy. So to build multiple use cases, we can actually do a low rank adoption. That means you can build an adapter layer on top of your foundation model, and then that adapter layer is specific to a specific use case. So given an example, you want to create a simple use case of denoising on based on the text to image diffusion model, then you can actually build a low rank adapter, that is LoRa, which is specifically trained only for that denoising task. And then you can actually lock your diffusion model and just train or fine tune only the LoRa architecture. And then while deployment, you have to just deploy only the LoRa on top of your diffusion model, and it will serve the task. So by using different kind of LoRa based on the same foundation model, you can build multiple level of different tasks. With using the control net, it provides more a next level of flexibility to the for the use cases. You can actually create a trainable architecture or a replica of the diffusion model, and then you basically log the your base diffusion model and only train the copy of the diffusion model for the specific task, thereby leveraging the capabilities of the diffusion model in terms of image generation, and also taking the advantage of your specific task and then training them on a specific way. So by using these techniques, you can build multiple different use cases based on your foundation model. Next, I will show some of the use cases which are very much possible to build using this foundation model. So, for example, you have an input image and then you want to convert this input image into a different style or the avatars. So, by using these foundation model and generative AI techniques, you can convert this input image into a 3D avatar, or you can convert this into a water color style. Further, you can actually just create interesting content by just scribbling on your screen. So you can just scribble and create a sketch, and then you can convert this sketch into a more realistic and appealing content, which can be done using these generative AI techniques. And these can create wonderful share-worthy content in a fraction of seconds. Another use case, what you can build using this generative foundation model is you can remove the unwanted object from the scene. So this is very popular and very useful tool to remove the content or unwanted objects from the scene. So you can actually mark and select this object, and then using the generative techniques, you can fill it that region with the background in a more realistic and aesthetic way, so without causing any degradation, and the output looks really realistic and appealing. So with this advancement, you can create a share-worthy content and create very creative and appealing content of to share with your family and friend and your circle. So by using different kind of techniques and these features, you can create a short stories just by using your smartphone cameras, and it will just create different kind of effects and create your best of the moment, and then you can directly share this content to your families. You can create best of the special captures by using the special effects on their scene, and also you can actually have use the intelligence of the camera to capture the best of the moments, create a useful memories and stories, and then this can be directly shared to your families and friends. So in this presentation today, we have seen that how the different aspect of the smartphone camera journey AI has been empowering. And we started with the lens, covering the sensor part of it, moving into the ISP, getting into once the image is captured, how we can do special processing on the image to make it more appealing and have some kind of special captures. And once the image is captured and saved it to the gallery, what kind of processing we can done, which can be done on the image to make it overall visual experience much better. And each of this journey has been powered by different AI components, And these AI components are not only powering this specific use case, but these AI components can also be used into multiple different scenarios and the use case in the industry. For example, autonomous cars, VR, AI robots, smartphones, healthcare, as well as smartphones or smart homes. So by using these techniques and using the power of AI, we can create and have multiple different visual experience and provide our customer a new set of experiences in the whole journey. So that's all from our presentation. Over to you, Girish, for the concluding remarks.
Thank you, Alok. I hope everybody finds this presentation very well. It is a very complex topic, but still we tried to cover all important aspects of the user journey: capture, spatial capture, edit, and create and share. There are many techniques discussed here, and as we reiterated, the major focus. There are two major objectives. One is the image quality, because image quality in all lighting conditions, even in extreme low light. So that is one very important, because once we reach to that level, then applying AI after that becomes very easy, and then we can do whatever we want. So image capture coupled with visual understanding of the world, this is a very crazy combination. And as I have been saying, this is like our eyes and brain working together. And when this combination is very rich and fantastic, anything is possible. So I definitely see this technology, eyes and brain, if it is deployed to robotics and many other things, I think it will change the world. And many things are possible. But now Gen AI has come, so it is helping us to have many creative outputs. So maybe one question to audience here. Now, because we have Gen AI, and we also discussed today sensor capabilities, camera sensors, and other things. So, do you feel without any sensor, can we generate 200 megapixel or 400 megapixel image quality with Gen AI? So that is a question to audience. But also we also would like to hear the question from audience. But thank you very much. Thank you for patiently listening, and thank you to Zinnov again.
Thanks a lot, Girish and Alok, for this insightful session. We have a lot of questions, and we encourage our audience to keep dropping their questions in the chat box to keep the conversation going. For the ones asking for the presentation recording of the session, please drop us a note at events@zinnov.com, and we will keep you posted on the same. So now let's get started with the question. So the first question that we have here is there any reason why only smartphone cameras are not as good as DSLR cameras? Is it because of the size and the form factor?
It's a good question. Yes, it is because of size and form factor. Because DSLR is very dedicated product only for capturing the moments and capturing the images. Whereas phone, as you know, we call it as a smartphone. Of
Mhm.
course, camera is one feature, but there are so many other things you want to do. You want to carry this device everywhere, and you want to do many other things in addition to the capture. So the form factor is one important thing, the space available and overall design and all these aspects. And that is the reason the all R&D folks are trying to solve this problem using many other methods. And over last 15, 20 years, you see the image quality has improved drastically. As I said, it almost has killed point and shoot cameras. And I'm very sure many DSLR pro experts would also turn to the smartphone cameras, at least for some scenarios, because its quality is very close to DSLR now.
Sure. And also, I think in the starting, there was a flow diagram that you folks showed. So somebody was asking, does that flow diagram holds good only for H.264 or 265 compression, or is it they can do it for other compressions as well?
Sorry, which compression? Can you please come again? I
So
couldn't.
they're asking, so there was a flow diagram, and does that flow diagram holds good for H.264 compression?
That is the last step, basically. So I think he is asking about the video compression or image compression. So the compression is always a last step. First is how best image or video quality you get. But if you want the best quality, then overall the size of the frame would be very, very high. And if you want to store this content or if you want to transmit this content, then it is important to reduce the size without much losing the quality. In that case, whatever the images finally you get, either image or video, we have very well-known standard. The JPEG is for the image, and H.264 or many other video compression techniques. So this is at the end, but before that, most important thing is how best image or video quality you can provide.
Okay, got it. So I think another question is on the AI/ML capabilities, basically. So what are your thoughts on having these AI/ML capabilities on surveillance cameras? I mean, somebody's mentioning that they know that the latest Hanwha Samsung serves few AI/ML capabilities on few models, wondering if they can expect smartphone camera capabilities also in the surveillance cameras.
So I think that's a very interesting question. And as we discussed in our last slide, that these AI components, which are currently empowering the experience in the smartphone cameras, are very much useful into our different domains also. So looking at if you talk about the surveillance cameras, there also the objective is to understand and localize the objects, um, have the feeling of like distinguish an object from the customer or the representative of the shop floors, or able to understand in terms of is there an intruder, right? So these kind of things are very much possible using AI with localization, recognition engines, as well as the detection engines. We can use the same techniques which are applied in the smartphone cameras. Of course, they can be tailored for other use cases such as surveillance or medical imaging and so on.
Sure. Thank you so much, Alok. So the next question which we have is, what are the core algorithms that gets applied while enhancing the image quality using AI?
Yeah, Girish, you would like to take it?
Can you please repeat the question?
Yeah. So what are the core algorithms that gets applied while enhancing the image quality using AI?
So one I explained is the AI demosaiking. If you remember, I explained using the color filter array, you get light intensity and one specific color, but you need to derive other colors using the surrounding pixel, and that is where the color accuracy and many other problems arise. So one important technique is using AI for demosaiking, so that you accurately get the colors from one specific color filter array. And there are many other things. One is the noise removal, because uh, sensor inherently will have a lot of noise, like short noise or different types of noises. So you need to understand the sensor noise and you need to build a noise model. Once you build a noise model, then using AI you can remove the noise. And on top of that, there are many other things, like you can improve the sharpness, and even for the tone mapping also you can use AI. These are all for the image improvement. But one more thing which we discussed today is about the understanding of the scene. If you understand the specific part of the project, whether it's a grass or it's a if it's a scenery scene or a specific part of the scene, then you can give different treatment to different parts of the image, and you can effectively use AI for local tone mapping and many other things actually.
And also, somebody is asking that, so at Samsung, do you develop your own models for generating the AI images? Or what are the basic models that you use for generating those AI images?
So I think this is a very interesting question, and I think so. This field is, as you know, that it is always emerging, and if you look at every day, there are new AI models for generative content creation are available. Very recently, we have seen Sora, which is an AI model which is able to create realistic looking video content, and that's where it was very popular, that many people started creating fake videos, and authenticity of these videos is becoming a very important aspect. And of course, Samsung is also very much interested in this topic, and a lot of researchers within Samsung is also working on this domain. And however, our focus is in terms of authenticity, in terms of providing the right content to the customer, and also providing or educating the customers that these contents are being generated through AI, so that these content should not be misinterpreted or misrepresented. So that's a social kind of responsibilities which we have, and I think we have to adhere to those responsibility and follow the AI principle by generating these AI contents.
Thank you so much, Alok. The next question that we have is, while AI offers us a lot of features to customize, enhance the images, videos, what's your thought in ensuring the authenticity of the videos or the images?
Yeah,
So, is
yeah,
this a
go
question
ahead.
for generative AI images or normal images?
Mm, Just they have mentioned AI only. So if you think the answer will be different for both the two things, it would be great if you can tell us the details.
No, so one is the actual capture, means
Mm-hmm.
camera is actually capturing, but you have to understand the limitation of sensor and the algorithm, and you have to meet the expectation of the user to give the best quality. So one type of AI is used to enhance the image quality, and
Okay.
it should able to handle the different complexities, lighting condition, and still, but it's still captured content and improving image quality. So this is an AI is used. This is one. Second is the
Yeah.
Gen AI, which Alok has explained, where the image is not captured, and then you, with your creative prompts and creative mind, you create a new image, and there also AI is used. So AI can be used everywhere. That was what our message was, and of course, you can customize with respect to your requirement.
Okay. So I think they were asking for basically any image that gets modified than the original one. So in that aspect, the question is, yeah.
No, image is not modified because user is capturing the content, right? He can see the preview and he can see the image. So what he's seeing in the scene, he's getting it. Of course, he's getting it with the enhanced image quality. And
Okay.
after that, there are editors and user can edit it if he wants to change the background, all that. So that is user control. But the thing
Yes.
is, whatever user is seeing in the camera viewfinder, the
Mhm.
scene and other objects, that we are capturing and we are enhancing to give the best image quality or video quality.
Okay. So just a quick question. So how do you think the AI-driven camera technology improves accessibility and usability for diverse user demographics?
So there are different aspects. So one is the user experience, and we really need to see the demands of different demographies and users of different ages. But typically, for so many years, if you have seen, the user experience is I just click and you get the image. And what we explained today is a lot of thing happens behind that actually. Okay, so this is a very common experience. You click and you get it. Everybody has kept it very simple. Of course, underlying complexity is very high, but still on top of that, there are problems. Like I sometimes I miss the moment, or I want to capture the best moment and all that actually. So some people want more control. Some people want AI to do the job. So that is one difference. So we have enabled all types of experiences. So people who want more control, they control overall camera and the way they want it. But like one more use case I explained is how to get the best moment where some event is happening or something. Like we are taking example of birthday. Now whether you want to enjoy the birthday moment or you want to be busy taking the picture, and you then you cannot enjoy basically the celebration. So in that, AI comes to your picture, you just start the camera, and then AI automatically understand event, what are the basic best moment into that,
Mhm.
and then it gives you, so you don't have to worry whether I will miss the moment or not actually. So there are different types of experiences, and some people want control, some people don't want control. This is, for example, also for the use case where a mother wants to capture image of the son, but son is moving here and there. Then when to capture is the main problem. So then AI actually helps, and it tries to capture the best moment and tries to give you. So different demographics, different age segment, and accordingly their needs, the experience has been built in different products of the Samsung.
Okay. So the next question that we have is, how do Gen AI and augmented reality AR collaborate to improve object recognition and scene understanding in real time?
Okay, I think when we look at a generative AI per se, there are two aspects. Slowly, if you look at now, these models are becoming more and more bulkier and complex. So we usually call them as a foundation model. So generally, traditionally, if you have to solve one problem, you will design one network for it. For example, if I want to solve the segmentation problem, I will have one network. If I want to do a localization problem, I will have another network. If I want to do classification problem, I will have another network. But by bringing this foundation model, these foundation model are capable to solve multiple tasks by using a single foundation model. That means a single model will able to give you instances of the segmentation. They will able to classify the object. They will able to localize the object. And these kind of foundation model are becoming more and popular because of their ability to understand the whole dynamics of the scene by using just a single network. So when it comes to AR, augmented reality, how it differs from the traditional smartphone camera is in the respect of the 3D, right? So when it is a smartphone cameras, usually it is represented into a 2D matrix, which is the array of RGB pixels. But when it comes to AR, usually it is represented into a 3D vector or other 3D representation. So these technologies which we apply onto the 2D domain can be very easily transformed to a 3D domain by basically retraining the data in terms of 3D and then having 3D localization or 3D aspect or 3D segmentation techniques. So by building these strong foundation model, I think it is very much essential, or we can actually apply these foundation model to the AR task for specific visual understanding and improve the overall experience for the customers.
Okay. So we'll take the last question for the session today. So do we foresee a future where the phone would have a low quality camera while hyper realistic photos are generated through AI augmentation, moving the focus from camera lens to edge computing and processing power?
Uh, do we really want to go to that? I think it's something which, as a human, we need to decide. I think there is how much realistic and how much AI content generation. So I think we need to have a quite a sweet balance between these two. Otherwise, we will be living in an imaginary world. So I think uh, we have to understand that we should basically use the power of AI and leverage on the power, but not give the power to AI. I think that's where I think we have to draw the line.
Perfect, Alok.
Absolutely said. So, thank you, Alok and Girish, once again for graciously sharing your insights and expertise on the topic. So, the session today not only addressed the question at hand, but was also able to spark further thoughts and discussions for sure. We hope that we will have the pleasure of working with you again in the near future. A special thank you goes to every one of you for your presence here today. We look forward to seeing you in the future Zinnov events. Take care and stay safe. Have a great week ahead.
Yeah, thank you so much.
Thank you.
Thank you, Zinnov. Thank you, Nopur. Thank you, everyone who attended today. Thank you very much.
Yes.
Yeah, thank you for the lovely audience, and thank you, Zinnov, for providing this platform. And we had a wonderful interactions with all the audience. Thank you so much.
Thank you so much, Alok and Girish.